Wow, it is another day, another time. We are doing now, of course, best 16. We've done best 8. We've done best. Okay, previously we did our last session. We did best 8. We had done previously best 10 and best 2. So now let's then take our last in this series of conversions, and that will be best 16. Best 16. Already we've been seeing the number of what? Best 16. The number of symbols equals to what? The number of symbols, let me just put number of symbols equals to number of symbols is equal to base itself. So therefore we have 16 symbols here. Okay, now we have a challenge. Our biggest symbol, traditionally our biggest symbol has been easy. Alright, it's been quite easy. Now our biggest symbol is equal to 16 minus 15. What am I saying? Not 16 minus 15. Got carried away. 16 minus 1, actually. 16 minus 1, which is equal to... I meant to exclaim at this point. 15 is two symbols. It's a 1 and a 5. So meaning, from 10 we've been having an issue. From 10 we had 1 0 already. So from 10 we can't have 10, it's two symbols. We want one symbol, that means 15. Alright, so what do? We say, okay, what are our symbols? Base 16 symbols. Understand this part first. Okay, alright, the base 16 symbols are 0, 1, all the symbols for base 10 up to 9. But then from 10, that would want to be two symbols. And we don't want two symbols in base 16. We want one symbol that all the way up to what? Up to the biggest symbol, which is supposed to be equivalent to 15. So we'll then say, okay, since we don't have such a symbol, let's create one with the alphabet. We say that 10 actually has a value of what? The A actually has a value of 10. It follows that B will be 11, C will be 12, D will be what? 13, of course E 14, and F 15. So our biggest symbol is, yes, not that, but F. But this F is equivalent to, oh God, drunk already, and I haven't even tested a single. Okay, this is equivalent, our F, which is equivalent to 15. So it's an F. This is an alphanumeric. We've got numbers and alphabet. So this is an alphanumeric base. We've got the biggest symbol. The biggest symbol is supposed to be have the value of 16 minus 1. That value is 15, and it is represented by what? By the letter F. Alright. So otherwise, once you understand that, the rest is a cruise. It's been what you've been doing forever. Let's start with the 20. Okay, let's say we take something like what? 33, right? Let's take 33, and we want to convert these to base 16. Okay, what do? We've said forever now that we divide our language by the base we try to go to. Alright, so 16 goes there, it goes there twice. 2 times 16 is 32 with a remainder of 1. Okay, now we try again. Any set of 16, because base simply means sets. So this here is 0, remainder 2. So actually our 33, I have a right to say 30 because that's base 10. I have a right to say 33, but I have no right to say 21 because 20 is actually is a what? Is actually meaning 2 tens. There's no other meaning for 20 except 2 tens. So this is a 2, 1. And obviously, if you leave it like this, 33 is equal to 21, which is an obvious fallacy. So what do? We have to put the little 16 down there. Okay, that's one example that is clear enough. How do you take it back? Let's take it back by proving it. And we would know that 2, 1, this means our base is 16. Okay, for this one the power is 0 for the units, and that one the power is what? Is 1 for the 16ths. Alright, so going forward you can see that this is equivalent to 2 times 16 to the power of 1 will obviously remain 16 plus 1 times 16 to the power of 0, anything to the power of 0 except 0. 0 to the power of 0 is not is a big exclamation mark, né? But 16 to the power of 0 is 1. 1 times 1 is 1. 2 times 16 is 32 plus 1, and we are back where we started. Okay, I do not really know whether I really must exhaust my even you at this stage, because I think you've got the game now. You know what bases are now. I think if I give you any base now, you should be able to function. But let's take another example. Let's say we have one example with the what, with the commas. Let's say we have I'll make it simple. Let's say I have something like 29 converted to no, I said with commas. So 29 comma, let's go and say 875 again. Okay, to base 16. All right, I'm putting numbers here that are not gonna carry, keep us going on and on and on and on. So I'm putting numbers that are gonna terminate nice and smart. The whole idea is to get the concept here. All right, so sometimes you find examples that are really a little upset. You find that you have to do an example where it never stops. You keep having to go on and go on and go on. What do you do if you miss such a scenario? Well, I would say our standard in engineering is 3 decimal places. That is a good standard. That is good practice. It is not a law, but it is good practice to use 3 decimal places. So I'll suggest that when it's 3 decimal places, when you get to 3 decimal places, just terminate them, because some examples go on forever. Unless some numbers are obvious, you can see they are eventually going to work out. But others, they seem to go on and on and on for, like, we have comma 3 at this point, you have comma 6 at that point, you have comma 9 at that point. It keeps going on. You can see that no, there isn't an obvious termination anytime soon. What you then do is just stick to our standard, our good practice, which is 3 decimal places. I would always cut off at 3 decimal places. Probably I could be kind and go to an extra decimal place. If I see it going on, I'll just stick to the 3, maximum 4. I won't do more than 4. All right, anyway, going back to this example, well, unless I'm told do it up to 5. Well, if there's a specific instruction from the test that says do it up to 5 decimal places, now you wouldn't then say you're going to terminate. You wouldn't then say it would be misleading for me to leave it hanging like that, to suggest that if there's a clear instruction from an examiner that says go beyond that, obviously that comes first. But then otherwise, in a general case where it's not mentioned, you leave it at 3 decimal places. It's good to indicate in brackets that it was actually what, 3 decimal places. All right. I'll make an example. Let's take an example. It's not base 16, it's a base 10 example. Let's say I'll make it at the corner here. Let's say I say divide 1 by 3. Okay, this would give us 0, 3, 3, 3. It would go on forever. It would never stop. So what do you then do? Well, it's the same number recurring over and over. So we could simply say 0, 3 and say it's recurring, either that way or with a bar, to say it's recurring. All right, maybe people don't know what I'm talking about, and then I will say sometimes it's better to assume, and then it means that this number will go on and on and on and on and will never terminate. Okay, if it's sometimes you get a scenario where the number is the same 3 digits or the same 2 digits are recurring, you just put the 2 dots on the 2 that keep coming over and over. But then now, if it was something that was giving you 0.637, different numbers all the time, you just go to 3 decimal. Let's say, for instance, you had an answer, whatever your fraction was, A over B. Let's say that was giving you 0.137, 137. You can see it's going on forever. 137. You can do 0.137. And you say all 3 are repeating part. If you had a scenario where C over D gave you something like 0.1374215, and you can see it's not about to terminate anytime soon. What you then say, you just say, okay, this is 0.137. Look at the next one. If it's below 5, you must round off. Then when you round off with below 5, this one stays as it is. So you just say 0, but you indicate that no, this was not my answer. I rounded it off to 3 decimal places. It's not good practice to just leave it like that. You must indicate that what I actually I thought this was going forever, so I just stayed with 3 decimal places. So my standard good practice is 1 decimal place is a little too, unless the numbers terminating like 0.5. 1 good decimal place is not good. 2 decimal places, yeah, but our good practice says 3 decimal places. It's not a law, but it's good practice. Now, I love the number 3 in engineering, because you talk of your kilos. It's a factor of 3. You talk of your mega, it's a factor of 3. You talk of your gig or whatever. You come back and you talk of your micro. You talk of your millis. You talk of, it's all factors of 3. So 3 sounds like a very magical number in what, in engineering. So good practice would say, please, let's stick to 3 decimal places. I prefer to tell my students, please, 3 decimal places. I even put as, you cannot run around it, because I put as an instruction in my paper that you must use 3 decimal places. Okay, so I play it safe. Now, then we have, let's go back to our base 16 now that we've cleared a little bit of the sound that I'm comfortable with generally. Let's go back to our number now. We're trying to convert this to what? To oh no, we are trying to convert a base 10 number, to base 16. Okay, we got carried away there, to base 16. Okay, if somehow when I was dealing with the comma side, it kept going on and on and on, I would suggest again 3 decimal places, please. But I chose a number that will terminate for us, because I normally, even when I set papers for my students, I normally try to say something that terminates, so that they don't really waste time doing, so they get confused. Some of them don't really get the message, then they keep going on and on and finishing their time. All right, so let's take our 29. You know it's a whole number, and what do we do with whole numbers? We divide by the base. Our base is 16, so 16 there will give us only 1. 16 times 2 is 32. 29 is below 32. So with the remainder now, our remainder, 29 minus 16 is actually 13. Okay, but then you remember this is equivalent to what? This is equivalent to our symbol D. Okay, all right. If it was 30, that would have been an E. If it was 31, that would have been what? An F. All right, so we say 16 again there, and you say it's a 0 with the remainder of 1. Okay, so what's our answer therefore? Our answer therefore is simply what? 16. Oh no, I keep doing this. 29. We're dividing into 29. We're trying to work out 29. 29 comma whatever is going to give us 1D comma whatever. All right, so now we do the decimal part, 0.875, and we maintain our comma line. We multiply by the base. On the whole number side we divide, on the comma side we multiply. Now, hey, tricky now. 5 times 16 will give us 80, because this is 30, 80. So this is 0. Remainder, I want to do it once. I can do it twice, but it's going to make me, I want to do it once. I don't want to write 2 numbers here. So I'm not going to do by 10 first, then by 6. No. I will do it once. So 5 times 16 is actually 80. So I'll say carry 8. 7 times 16. All right. If 5 times 16 was 80, it means that we are going to 96. Then from 96, another 16 will give us 112. Okay, 112. So this will be 2 remainder 112. Okay, let me first verify. 1696, and then yes, it's 112. Now, then 8 times 16, that will be what? If it was 112 with 7, with 8 is going to be, am I going to terminate here? I'm worried whether I'm going to terminate here. Let me double check something. 5 times 16, 5 times 3 is 30. 5 times that plus 3, that is 80. Yes. Now, there's my 8. So I forgot something here. Yes, I knew I forgot something. I forgot to add the carry. 112 was just the clean multiplication without adding the carry. So it's 120. Why? I knew something was wrong. 120 because 7 times 16 will give us 80 plus 32. That will be 112. But plus the 8 there, that is where I was going wrong. That will be 120. So we write the what? We write the 0 and we carry 12. Okay. Now, 8 times 16, if 8 by 7 was 100 and what? 112. And then 8 times 16 is an extra 16. That will be 12 and 16 is 28. So that's 128. 128 plus 12 is 140. So this is 14. Okay. Now, we kept our 3 decimal places, all zeros, we are lucky, and this 14 here is actually equivalent to, we'll take this down, but remember that the 14 is actually equivalent to what? To our E. So our answer here is 0.875. The decimal part is equivalent to 0.E. So our base is 16. Right. I hope that wasn't a little complex, having to make a little mistake there. I hope it didn't throw people off and get them confused. But if you go again, just for clarity, I could have said A75 times 10 and then added whatever I get from A75 times 6. But it's still the same thing as 5 times 16. 5 times 16 is 80. So it was 0 carry 8. What I done wrong was 7 times 16 gave us what? Gave us 112. But in my haste now, I put 112 sort of adding the 8 first. So after adding the 8, we've got 120. So I put the 0 and I carry the what? The 12. Now 8 times 16, it's 1 extra 16 on the 112. So it's 128. But plus the 12 that we carried before, it's 140. And voila, we are perfect. But then remember the 14 is actually equivalent to E. All right, we mentioned this here. Okay, maybe if people forget, this is 10, this is 11, this is 12, this is 13, this is 14, and F is 15. So our answer is that. But I guess some people are doubting Thomas's. So what we then do is we then say prove it. We then say, okay, prove. It's 1 T, comma E, base 16 being converted to base 10. Now this is 16 to the power of 1. This is 16 to the power of 0, the unit. This is 16 to the power of minus 1. This therefore is what? This therefore is 1 times 16 to the power of 1 is 16 plus D is actually for the West 13. So this is 13 times 1, because 16 times what? 1 by 16 to the power of 1, which is 1 times 16. D, which is 13 times 16 to the power of 0, which is 1. 13 times 1. And then, let me make sure I don't lose my 1 here. And then, that one there is plus, E is 14. That is 14 over 16. We'll make our life easy there by dividing by 2. That will make it 7 over 8. Okay, so then now, what we can then say is, obviously, this part is 16 plus 13. That is a 29. Okay, comma 8 into 7, 0, comma into 78 into 70. Again, we have an 8. 8 times 8 is 64. Now 70 minus 64 leaves us a 6. 8 into 60, that's 7, because 8 times 7 is 56. So 60 minus 56 is a 4. 8 into 40 is a 5. And we started with 29,875. We end with 29,875, and we know we did it nice and super. I don't know. It's a little bit, I don't know whether, I think the best practice is for students to do more of the work than the educator. And so I really suggest now that you go through your books and you look at the examples in your books. Try and go through. If there's any questions, I'm only a contact away. Try and contact me and I'll assist where you've got issues and questions. All right, then. I hope that was a joyful exercise. Latest.